Hey y'all. Today's objective is direct variation, and you should have your outline with you. So, a direct variation is a relationship when y varies directly with x. Hence, direct variation varies directly. There is a such thing as an indirect variation, but we don't cover that in 8th grade. So when y varies directly with x, the equation can be written y equals kx. We've already worked with slope-intercept form, y equals mx plus b. So it's kind of like the first half of slope-intercept form, y equals kx. K is called the constant of variation. In slope-intercept form, m is the slope of the line. But in a direct variation, k is called the constant of variation. That means that's how much it's constantly changing. Variation means change. Constant stays the same. So you'll see in some problems, the constant variation is going to be that number, kind of like that scale factor, that number that's constantly going up or going down, like slope. You can find k by y over x. And how I got that was I started with the direct variation equation. And if I wanted to solve for k, I would divide both sides by x. And so k is equal to y over x. K cannot equal 0. It's just not a direct variation if k is equal to 0. So our first example, I put it up here. I think on your handout, you need to fill in the numbers. But I'm going to show you how to decide if the table is a direct variation. Do these form a direct variation? We need to test to see if their k's are the same. I'm going to come on this side. So we need to test the k's. K's equal to y over x. So for every table, I'm going to test the value y over x. So for this, it's 4 over 1, which is 4. 8 over 2, I'm just dividing y by x. I'm looking at that ratio. And 12 over 3, which is 4. If all of the k values are the same, then this is a direct variation. So the answer is yes, it's a direct variation. And the k value is 4. The constant variation for this table would be 4. So that's how you tell if it's if it's a direct variation. B, we have 3, 4, and 5, 9.6, 12.8, and 17. We need to test the k's to see if it's a direct variation. I'm going to set up my ratio. K is equal to y over x, 9.6 over 3. And you can use your calculator, and you always want to reduce, so that would be 3.2. 12.8 over 4 is 3.2. And then 17 over 5 is, type in your calculator, 3.4, because it's really 3 and 2/5. That would be the mixed number. So 3.4. Since this one is different, even though these two are the same, this one is different. This is not a direct variation. The answer is no. This one does not form a direct variation because I tested my y over x ratio, I tested my k values, and they are not all the same. So down here, C, on the end, I'm going to come back to this side. I'm switching it up. I need to test out my y over x. So 10 over 2 is 5. Now, you are more than welcome to try this one, but I see 5 over 4 is not going to equal 5. That should be easy for you to see. 5 divided by 4 is not going to equal 5. 10 divided by 2 is 5, but 5 over 4 is not 5. So I don't even have to test that middle one. I can see that the answer is no. This is not a direct variation because my k's are not constant. And your k has to be the same for every point in your table. So that's example 1, how to tell if it's a direct variation. Okay, got to figure out where to put my board. All right, example 2, do these equations and graphs form a direct variation? Do these equations and graphs form a direct variation? So let's just quickly, the equation for a direct variation is y equals kx. If the equation is in that form, or you can get it to that form, then it is a direct variation. So letter A, y equals 2.3x, the answer is yes, it's a direct variation because it's in the form y equals kx. Letter B, y equals negative 3x. K can be negative. So this value right here is your k, and this value right here is your k. And that's totally acceptable. So this answer is yes, it's a direct variation because it's in the form y equals kx. Letter C, just checking the time. Letter C is y equals mx plus b. But because of our plus b, it is not in the form y equals kx, so the answer is no, it's not a direct variation because of the plus b, which in this case is really a negative 1. But that is not a direct variation. Letter D looks a little different. So if you look at it and you're like, well, I'm not sure. It doesn't have a plus or a minus. So we see that it doesn't have a plus or minus, but the x is in the denominator. And if you're not sure if that's okay, let's see if we can get it in the form of y equals kx. I already have y by itself. So if I were to multiply both sides by x, I would have x times y equals 5. But then to get y by itself, I would divide by x, and then I'm right back where I started. Because x is in the denominator, this is not a direct variation. This is not a direct variation because it's not in the form of y equals kx. If the number was in the denominator, for example, y equals x over 5, that would be okay because that's like 1/5 times x. And k would be your 1/5. But if your x is in the denominator, that is not a direct variation. And so that's why the answer is no, it is not a direct variation because we cannot write it in the form of y equals kx. Now when we're talking about graphs, the graph of a direct variation is going to be very, very similar to a proportional relationship, which we've talked about. A proportional relationship, it has to have a constant of variation, a constant rate of change that's going to be a linear, and it needs to go through the origin because it doesn't have a y-intercept because it's just in the form of y equals kx. It has to go through the origin. So the first one, let me show you this. How is this written? Okay. So that's the first one. Copy that down. All right, those are your 4. And if you had a graph and you were asked, does this graph represent a direct variation? Here is how you would work it. First of all, does it go through the origin, and is it linear? Those are your 2 big things. This equation, first of all, it doesn't go through the origin, and it's not even linear. It's curved. This is actually an exponential function. But the answer, no, it's not a direct variation because, number 1, it doesn't go through the origin, and number 2, it is not linear. So we'll call this, what are these on your, they're not even, so we'll say 1, 2, 3, 4. Sorry. Number 2, this is a linear equation and it goes through the origin, even though it might not look like it goes through the origin, and so the answer is yes, this is a direct variation. If we wanted to find the k value, we would find the slope because that's the same place that it's at. Number 3, this also is a linear equation and it goes through the origin. Even though it is a negative, it still goes through the origin and it's linear. So this is, yes, a direct variation. And then number 4, it is linear, but it does not go through the origin. So the answer is no, it's not a direct variation. So like I said, it's similar to proportional relationships. It has to be linear and it has to go through the center, the origin. All right, example 4, here is the whole, this is like, gets down to the nitty gritty of this lesson. This is what we're talking about. Solving problems using direct variation. So we need to find the missing value. There are a few steps to this process. Number 1, you want to solve for k. And remember, I showed you before, I'll show you again how to get a k. Number 2, you want to put it into your direct variation equation, y equals kx. After you find your k, you put it into your equation. And then number 3, you want to find the missing value. So for this first problem right here, we are going to find the k by substituting in y over x. I'm going to take this point. I can't use that one because it's missing a y. So y over x is 6 over 4, which reduces to 3 over 2. There's your k value, 3 over 2. Now that you have your k, we can rewrite the equation y equals kx. Y equals kx. So that's number 2. Now number 3 is to finish the problem. We are missing the y. That's what we're missing. We know our x is 9, so we're going to type into the equation, and our y value is 27 over 2. 27 over 2, 9 times 3 is 27 divided by 2, or if you're going to put it into a decimal, it's going to be what, 13.5 maybe? Okay. So again, follow the steps. In example B, if y is 16 when x is 10, find x when y is 22. So first we need to decide what k is. Y over x, 16 over 10, divide both sides by 4, and we get divide both sides by 2, and we get 8 over 5. So first you're going to find k. Once you find k, you're going to put it into your equation. Y equals 8 over 5x. That's step 2. Then we solve the problem. In this example, we're looking for x, and we have y. So we're going to plug that in. 22 equals 8 over 5x. You have a calculator, so you can solve it. Divide both sides by 8/5, or multiply by the reciprocal. Either way, if you divide both sides by 8/5 or you multiply by the reciprocal, you're still going to come out with x equals 55 over 4 is what I have because I just kept it in fraction form. If you are going to type it in your calculator, then you're going to get, I don't know, 13 point something or 14 something. All right, letter C. If y is 18 when x is 6, find y when x is 1. Again, we're going to find k is 18 over 6, which is 3. So my equation is y equals 3x. Find y when x is 1. Well, if x is 1, then 3 times 1 is 3, so y is equal to 3. That was an easy one. All right, you try D. Pause it, you try D, and then press play when you're ready to see the answer. K is 16 over negative 8, which is negative 2. So y equals negative 2x. I know my y value, so negative 14 equals negative 2x. Divide by negative 2. So x is equal to 7. Now you might be wondering like how this is different from a proportion. And it's very similar to a proportion. The difference is you can't have x in the denominator like the example I just showed you. Whereas in a proportion you could have x in the denominator. And then the vocabulary is different. If you have a word problem that says varies directly, then you'll know what kind of equation you're looking for. All right, so real world number 5. The distance you travel varies directly with time. If you travel 147 miles in 3 hours, how long will it take you to travel 245 miles? Now, we need to know x and y. X is going to be your independent variable. Y is your dependent variable. In this example, your time has to be your independent because you're going to travel 3 hours and get a distance. You don't travel a distance first and then get a time. It's going to be how long you travel is your distance. And this is our y. To find our k, we do 147 over 3. 147 over 3 is 49, so our k is 49. Y equals 49x. There's my equation. So I found my k and I wrote my equation. Now I need to plug it in to find 245 miles. 245 miles equals 49x. Divide both sides by 49, and x is 5 hours. X is 5 hours. Again, you could have set up some sort of proportion to solve it, but when asked for a direct variation equation, you have to be able to give this equation in the form of y equals kx. Okay? So on the last problem, you have a U-try. All right? Somebody's selling raffle tickets, and you have money, you have tickets. You have to decide which one is going to be your x and which one's your y. I want you to write your equation. Is it a direct variation? And then what is the constant of variation? And we are going to talk about, someone remind me, we're going to talk about it in class the next time we're together.